Welcome to another Explainer. I am absolutely thrilled to have you here today. Look, let's just be real for a second. If you've ever sat down at your desk, stared at a Cambridge computer science past paper, and felt like getting top marks requires some sort of ancient dark magic, you are definitely not alone. It can be incredibly overwhelming. But here is the ultimate secret I want to share with you right off the bat. Magic spells are really just structural frameworks. That's all they are. If you cast the right spell, meaning you use the correct analytical framework, you unlock maximum marks every single time. Today, we are stepping into the role of the wizard to completely demystify the Cambridge exam strategy. Now, we're going to be specifically focusing on the rigorous demands of Syllabus Code 9618, but listen carefully because the golden rules we are discussing today absolutely apply across the board, whether you're sitting 0417, 0478, 0983, 0984, or 2210. Okay, let's dive right into this. We are tackling a topic that literally strikes fear into the hearts of so many students, yet it holds the absolute key to securing incredible marks. I'm talking about lossless compression principles and applications. By the end of this explainer, we are going to transform those confusing, panic-inducing past paper questions into a crystal clear, highly structured roadmap to success. Let's get started. I want to start by showing you something incredibly important. The sheer weight of this quote, which comes directly from the principal examiner's report, is absolutely vital. Read it with me. Mastering lossless compression appears in every examination series. Let that sink in for a second. Every single series. This isn't one of those obscure, niche topics that you can just skim over the night before the exam and hope it doesn't show up. There is no hiding from it. It is a fundamental, non-negotiable pillar of the theoretical foundations of computer science. Whether you are looking at data representation, network transmission, or deep algorithm evaluation, lossless compression is going to be there waiting for you on that exam paper. The stakes are incredibly high here. So think of this explainer as your personal, behind-the-curtain examiner's playbook. I am going to show you exactly what the Cambridge examiners are hunting for when they grade your paper. Word for word, structure for structure. We're doing this so you never, ever drop a completely preventable mark again.
So, the absolutely crucial point we need to address is the question you see right here. Why do students find applying concepts to unfamiliar contexts so incredibly hard? To understand this, let's picture a real Cambridge past paper scenario in our minds. Maybe a really tough question from a 9713 or 9618 paper. Imagine a dynamic split screen right now. Over on the left side, we have student Alex. Now, Alex is a really hard worker. Alex has read the textbook cover to cover. But when the exam starts, Alex panics and overloads their answers with raw computer science facts. It becomes this massive, unstructured brain dump of superficial breadth, but with absolutely zero analytical depth. The examiner's red pen is just slashing through that paragraph, because despite all those facts, Alex didn't actually answer the specific question asked. Now look over on the right side. Here we have student Sam. Sam definitely knows the material, maybe even better than Alex, but Sam feels the time pressure, panics, rushes through the question, and completely misses the specific command word requirements. Sam might successfully calculate a complex binary representation, but then totally fails to draw the required evidence-based conclusion that the command word demanded. And what happens? More red ink. Both of these approaches, while super common, are deeply flawed because they lack a structural framework. They are winging it under pressure, and that is a recipe for losing marks.
To fix this completely, we need a reliable roadmap. Here is our agenda for today's explainer. First, core concepts and principles. Second, the technical methodology. Third, the deconstruct, solve, evaluate framework. Fourth, top examiner warnings. And finally, number 5, the method mark strategy.
Let's jump straight into Section 1, Core Concepts and Principles. This is where we shift your mindset from memorizing superficial facts to developing true analytical depth. Let's really break down the difference between the kind of answer that loses marks and the kind that gains top marks. Superficial breadth versus analytical depth. The Cambridge Assessment Framework explicitly, and I mean explicitly, prioritizes analytical depth. Superficial breadth is simply listing raw facts. It's writing down something like, lossless compression reduces file size without losing data. Okay, great, that's technically true, but that is bare minimum baseline stuff. It won't get you the high marks. Analytical depth, on the other hand, requires structured reasoning, precise technical definitions, and proving causal relationships. For instance, rather than just defining what compression is, you need to show the examiner exactly how run-length encoding actually compresses a string of data by replacing repeating characters with a single character and a numerical count. Then, you take it a step further. You explain how that specific algorithmic efficiency directly impacts network transmission speeds, or how it alters the storage space complexity on a server. Connecting those dots, that is what demonstrates top-tier analytical depth. Before we continue, subscribe to our YouTube channel AC Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
And how do we actually guarantee we write with that level of depth under the pressure of a ticking clock? Here is our very first magic spell, the PEL framework. If you want to know exactly how top students structure their analytical answers for maximum marks, this is it. Step 1. Point. You need to make your core technical statement crystal clear right out of the gate. Don't bury the lead. Step 2. Evidence. Extract highly relevant data directly from the binary representations or from the specific context given in the prompt, like isolating a specific run-length encoding sequence from the data table provided. Step 3. Explanation. This is the real meat of your answer. This is where you clearly outline the causal relationship. How does the algorithm actually execute step by step to compress that exact piece of data? Walk the examiner through the mechanics. Step 4. Link. Connect your explanation all the way back to the specific context of the question or a larger cross-topic principle. If you use this PEL framework, you naturally avoid the chaotic brain dump traps that our friend Alex fell into earlier. You are no longer just hoping something sticks, you are carefully engineering an answer that commands marks.
Moving right along to Section 2, the technical methodology. Because as we know, writing a perfectly structured paragraph is really only half the battle when it comes to computer science. Algorithmic thinking in lossless compression requires a relentless, step-by-step decomposition process. Imagine you're in a fast-paced workshop scenario right now. You've got 60 seconds on the clock, and you're faced with a massive, unfamiliar problem data set. Maybe it's a huge string of binary or a weird, novel data structure you've literally never seen in your textbook. You need a systematic processing sequence to handle it without panicking. First, you scan for binary data. Your immediate required action is to accurately extract the representation. You pull the bits out, you group them logically, you make sense of the raw input. Next, you look at calculations. When you calculate the compression ratio, you must execute with incredibly clear, precise notation. No messy, chaotic scribbles in the margins that the examiner can't read. Finally, conclusions. This is where you draw your evidence-based insights. You absolutely do not just guess or state a generic fact, you prove your conclusion based exclusively on the specific data you just finished extracting and calculating. You must demonstrate that you can design the algorithm, implement the solution logically, test it thoroughly, and evaluate its performance. This rhythmic, highly mechanical process is what guarantees you pick up marks even when the initial question looks completely alien to you. Stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_GCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_GCS and turn on all notifications so you never miss our weekly exam strategy sessions. Systematic processing is your key to Cambridge success, and we are here to help you build that system.
Let's dive into Section 3, Deconstruct, Solve, Evaluate. This is your ultimate procedural mantra for those moments when the exam paper tries to overwhelm you.
Whenever you flip the page and are faced with a massive, intimidating block of text or a highly complex problem, I want you repeating this exact rhythm in your head. Deconstruct, solve, evaluate. Higher-order assessment objectives absolutely demand this specific flow. It is exactly how you break down what looks impossible into something highly manageable. Let's break this framework down step by step so you can use it. Step 1. Deconstruct. This is where you identify all the given information. You pull out the command words. Are they asking you to describe, explain, or evaluate? You isolate the parameters. You find the exact file size, the transmission speed, or the specific data type mentioned in the prompt. You literally dissect the question. Step 2. Solve. Now you break the problem into logical, bite-sized steps and execute them systematically. You apply your calculations with that clear notation we talked about. Step 3. Evaluate. This is the step everyone forgets. You must step back, look at your answer, and check it for reasonableness. Make justified recommendations. Think about it. If your calculation says a lossless compression algorithm somehow compressed a 10-megabyte video file down into 3 single bytes, your internal evaluation should immediately trigger a massive alarm that something in your math is deeply wrong. If you mentally apply this 60-second speed scan technique to complex datasets, you will never ever freeze up in an exam room again.
Now you might be wondering, what does evaluation actually look like at a strict A-level standard? When Cambridge examiners are assessing those high-value, higher-order objectives like algorithm quality and performance, they are hunting specifically for these exact focus areas on the matrix. First, time complexity. They want to know if you understand how the execution speed scales as the volume of data increases. Does the algorithm slow down exponentially when the file gets bigger? Second, space complexity. What is the memory efficiency of, say, the dictionary being built during the compression process? Is it eating up all the available RAM? And third, which is incredibly crucial, edge cases. What is the boundary performance? Examiners love this. What actually happens if you try to compress a file using Huffman coding, but the file has absolutely no repeating characters whatsoever? How does the algorithm behave then? Does it actually make the file larger? Highlighting these specific performance metrics in your answer proves to the examiner that you don't just know how to regurgitate the code from a textbook. It shows you deeply understand how that algorithm behaves in real-world, unpredictable environments.
Moving into Section 4, Top Examiner Warnings. It is time to learn from the mistakes of thousands of past students so you don't repeat them.
We are going to do a quick find the flaw exercise right now. The Cambridge principal examiners publish detailed reports every single year, and honestly, every single year they practically beg students to stop making the exact same preventable mistakes. So let's look at the top 3 traps students consistently fall into when dealing with lossless compression. First up, examiners report that students constantly confuse cause and effect. For example, you might confidently state that a file transfers faster over a network, but you completely forget to explain that the compression algorithm caused a reduction in total bits, which then affected the faster transfer over a limited bandwidth. You have to explain the whole chain. Second flaw, students forget to check boundary conditions and edge cases. If you write out an algorithm but you don't explicitly state how you would test the extremes, like feeding it an entirely empty file or a file with zero data redundancy, your solution is considered incomplete by the examiner. Third, and perhaps the most devastating, providing answers that are not specific to the given context. If the exam question is asking you about compressing a highly detailed, high-resolution medical MRI image, and you give a generic, rehearsed answer about compressing simple text files, you are going to lose the marks. Context is literally everything. Ignoring the specific scenario the examiner built for you destroys an otherwise perfectly good, technically accurate answer.
And finally, we arrive at Section 5, the method, mark, strategy. I need you to pay very close attention to this part because it is an absolute game changer.
Examiners award marks for the process. Method marks can save you. Listen to me very carefully on this. Thousands of students lose marks unnecessarily every year simply by not showing they're working. It is heartbreaking to see. Let's say you are working through a brutal calculation for a compression ratio, or a really long binary conversion. You get to the very end, but somewhere along the line, you press the wrong button on your calculator. Your final answer is completely 100% wrong. You might think you've lost all 5 marks for that question, but here's the secret. You can still get almost full marks. How? By systematically laying out your entire process. If you clearly identify the key elements, apply the relevant formulas, and execute the analysis with incredibly clear step-by-step working on the page, the examiner can and will award you method marks. Examiners are not trying to trick you. They are literally scanning your paper, looking for a reason to give you points. They want to see how your brain works. Make it easy for them by showing every single logical step of your journey, even if the destination ends up being a little off.
Consistent application of these frameworks leads to truly dramatic improvements. Think back to Alex and Sam from the beginning of our explainer. They were losing massive amounts of marks not because they weren't smart enough, but simply because they lacked a system. When you replace exam panic with a structured process, the results speak for themselves. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Structuring your answers changes absolutely everything.
So, let's wrap this all up. Here is your complete answering system, your ultimate success blueprint. Number 1, command word decoding. Don't rush like Sam. Pause and know exactly what the question is demanding of you. Number 2, Peel framework application. Use point, evidence, explanation, and link to achieve true analytical depth. Number 3, the deconstruct, solve, evaluate flow. Use this as your 60-second processing mantra to break down complex data. And number 4, method mark optimization. Show every single step of your work to capture those lifeline points. If you rigorously follow this blueprint, your mark potential reaches 100%. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCSE and click that bell. Don't let another exam pass you by without being prepared.
Before we go, I want to end with a fun, practical challenge to really hack your memory for exam day.
Your challenge right now is to create a unique mnemonic device using the first letters of key lossless compression terms. Seriously, the weirder and more ridiculous it is, the easier it will be to remember when you are sitting in that quiet exam hall. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here. I will see you all in the next explainer. Keep studying smart, keep applying those frameworks, and go get that A star.